Hello guys, hello grade 11. Let's continue with our assignment on 3.2. Let's read the information. They are saying in the figure, K, L, M, N are the vertices of a parallelogram. So we are dealing with a parallelogram here. So they are saying K, L, M, N. So this shape that we see here, it's a parallelogram. This quadrilateral, it's a parallelogram. Now for us to work with a parallelogram, we must know the properties of a parallelogram. So very important, grade 11s, this is what you must know. Opposite sides of a parallelogram are parallel and equal. This is one of the property of a parallelogram. Opposite sides are parallel and equal. So I'm going to take the side KN, which is opposite to LM, and say these two sides are parallel. Kn is parallel to Lm. Not only parallel, but they are also equal because we are dealing with a parallelogram. In a parallelogram, opposite sides are parallel and also equal. So Kn is parallel to Lm. Let me write it here on top. Kn is parallel to Lm. That's not the only thing. Kn is also equals to Lm. And we know that Lk is parallel also to Mn because Lk is opposite to Mn. So these opposite sides of a parallelogram are parallel. So I will say Lk is parallel to Mn. Not only parallel, but also equal. Lk is equals to Mn. This is what we know about a parallelogram. Another thing that we know about a parallelogram, another property of a parallelogram, something very important that you must consider about the parallelogram is that the diagonals bisect each other. The diagonals bisect each other. So the diagonals of a parallelogram bisect each other. So if I say we have got a diagonal KM, this is a diagonal of a parallelogram, KM. This diagonal will bisect the diagonal LN. So the diagonals bisect each other. So what we mean here is that the diagonals, they divide each other into two equal parts. So it means that this part is equals to this part. And this part is equals to this part. So the diagonals bisect each other. They divide each other equally. Now, there is something that you have to consider about this point here, where they bisect each other. That point is the midpoint of both our diagonals. So the diagonals of a parallelogram, they have got the same midpoint. So this idea of having the same midpoint comes from the fact that the diagonals of a parallelogram bisect each other. So if I give you a diagram here, and I say to you, this is a parallelogram. Let me say A, B, C, T. So what you have to know is that the diagonals of this parallelogram, the diagonal DB bisect the diagonal AC, which implies that the midpoint of AC is also the midpoint of DB. So the diagonals have the same midpoint. So now let's continue with working on this question 3.2. For now we know a lot about a parallelogram. Diagonals bisect each other. Opposite sides are parallel and equal. And also the opposite angles actually of a parallelogram are equal. So we can say the angle K is equals to the angle M, and the angle L is equals to the angle N. These opposite angles of a parallelogram are equal. So opposite angles of a parallelogram are equal. Okay, I think now we are ready to look at the question. What does the question want? Determine the gradient of LM. This should be a giveaway. This should be a giveaway. Finding the gradient should be simple. Small m representing the gradient, and you say LM. So you are saying, I'm looking for the gradient of LM. So you are going to say y at L minus y at M over x at L minus x at M. This is what we call the gradient formula. So I'm using the gradient formula to calculate the gradient. Most of the teachers, they will say y2 minus y1 over x2 minus x1. So you can still say y2 minus y1, that is acceptable. So now what is my y at L? So I'm going to go to the point L. Here it's L, and look at y. This is my x. This is my y. So my y is -3. So I will say -3 minus, go to my y at M. This is my x. This is my y. So I'm going to subtract -2. Make sure that you write that -2 over x at L. You come to the point L. What is x at L? -5. So you say -5 minus, you subtract x at M, which is 2. So you will find the gradient of LM, which is -3 plus 2, it's -1. So it's -1 over -7. So the gradient, it's 1 over 7. It was a giveaway. Gradient of LM is a giveaway. Now on 3.3.2, they are saying calculate the size of alpha. Give your answer correct to 1 decimal place. So we have to find the size of angle alpha. Let me erase. This kind of problem we see more often, guys. Even in grade 12, we see this kind of a problem. What we have to identify or to spot about the angle alpha is that is the angle between the straight line, this straight line, and the x-axis. Here it's my x-axis. Okay, so the angle measured from the x-axis to the straight line. So if I give you something like this, let's say we have the y-axis, we have the x-axis, and I give you a straight line that cuts the x-axis. And now observe that this angle is measured from the x-axis to this line. So this angle can be found by using the formula tan theta equals to M, whereby M represents the gradient of the line which cuts the x-axis. So here I will say tan of theta, my theta, in this case my angle is alpha. So I will say tan of alpha equals to M. M, I'm referring to the gradient of that line that cuts the x-axis. So what is the gradient of LM? We found 1 over 7. So we say tan alpha equals to 1 over 7. Now to find the angle alpha, we must first find the reference angle by doing the second function of tan. So you say second function of tan of 1 over 7. So let's see how much we get. We say 1 divide by 7 equals to, now I want to do second function of the answer. So I will say second function, yes, it's 8 comma 1. It's 8 comma 1. So they said calculate the size of alpha, give your answer correct to 1 decimal place. Yes, it's 8 comma 1. My reference angle, I don't need to chat. My reference angle is 8 comma 1. So, okay. And then I have to observe now, this is in the first quadrant. 1 over 7, actually tan is positive in the first quadrant and in the fourth. So alpha appears to be an acute angle. So my alpha actually, in this case, is my reference angle. It's 8 comma 1. So that was 3.2.2. Let's go for 3.3.3. Determine the value of K. I love the problem of 3.2.3 because it brings forth one of the mathematical idea which is called collinear point. If you look at the point L, A, and K, the point L, A, K, we call them collinear points. Collinear points are the point which lies on the same line. So if I give you a line and I give you a point and a point and a point, I give you 3 points on the same line, we call this point collinear point, point that lies on the same line. So for me to find, in this case, the value of K, which is K is found on the point A here. For me to find the value of K, I will say the gradient M of LK is equals to M of LA. I will say LK and LA, they have got the same gradient. These are the point on the same line. So if you are using the point on the same line to calculate the gradient, your answer must be the same. So the gradient of the line LK, the line from L to K, is the gradient of a line LA. After all, this is the same line. So I'm going to say, okay, the gradient of LK, it's minus 3 minus 2 over minus 3 minus 2 over minus 5 minus 0 equals to, now I will calculate the gradient of LA, which is minus 3 minus 0 over minus 5 minus K. So minus 5 over, this is 1 on the left. If you press it on a calculator, it's minus 5 divided by minus 5, it's 1. So you are having minus 3 over minus 5 minus K. Now from here you can do cross multiply. You say 1 times minus 5 minus K, which is minus 5 minus K equals to minus 3 minus K. You group like terms equals to minus 3 plus 5 minus K. Minus 3 plus 5 is 2. Therefore, K is negative 2. So the value of K is negative 2. Now they say, determine the numerical value of the coordinates of n. We are solving 3.2.4. The numerical value of the coordinates of n. So we are looking for the coordinates of n. I will approach this one by doing this. I will first calculate the midpoint of Km. And the midpoint of Km, I know that it is also the midpoint of Ln because we set the diagonals of a parallelogram bisect each other. So the diagonals must have the same midpoint. So the midpoint of KM is also the midpoint of LN. So I will say midpoint of KM. Let me calculate the midpoint of KM. How do we calculate the midpoint of KM? You take X at K, you add X at M, you divide by 2. To find the Y midpoint, you take Y at K, you add Y at M, you divide by 2. So what is X at K? It's 0. What is X at M? Is 2. What is Y at K? Is 2. What is Y at M? Minus 2. You divide by 2. So here 0 plus 2 divided by 2, it's 1. 2 plus minus 2 divided by 2, it's 0. So it means that the midpoint of KM, it's 1 and 0. Okay. Let me confirm. 0 plus 2 divided by 2, 1. 2 minus 2, oh yes, 0. So the midpoint of KM, it's 1 and 0, which means that the midpoint of LN also should be 1 and 0. Because I said the diagonals of a parallelogram have the same midpoint. So I will say, okay, the midpoint of Ln now it's 1 and 0. So I will say X at L plus X at N, if they are divided by 2, I should get 1 because I know the midpoint of X of L and N. The X midpoint is 1. So I say if I add the two values of X at this point, L and N, and divide by 2, I should get 1. So I know X at L is minus 5. So I will say minus 5 plus X at N divided by 2 equals to 1. So you do cross multiply now. You say 2 times 1 is 2. So it's minus 5 plus X at N equals to 2. X at N equals to, take minus 5 to the right hand side. It's going to be 2 plus 5, which becomes 7. So X at N, it's 7. So the X coordinate at N is 7. Now I have to find the Y coordinate. How do I find the Y coordinate? I will say, I know the Y midpoint of Ln. If I take Y at L and add Y at N and divide by 2, I should get 0. Remember, we said the Y midpoint of Km is 0. So it means also the Y midpoint of Ln, it is also 0. Y at L is minus 3. So minus 3 plus Y at N divided by 2 equals to 0. If you do cross multiply, you will have minus 3 plus Y at N equals to 0. 2 times 0 is 0. Therefore, Y at N is equals to 3. So the coordinates of N, it's 7 and 3. That was 3.2.4. Now let's go to 3.2.5. Show that the triangle KLM is an isosceles triangle. Okay, the isosceles triangle is a triangle which has got two sides that are equal. So they are saying show that KLM is isosceles. So let me identify the triangle he's talking about. He's talking about L, M. So he's saying show that this triangle is an isosceles. So isosceles must have two sides that are equal. So I'm going to calculate my sides, the value of these three sides, and look for the sides that are equal. So I will say, okay, let me measure the distance from K to L using the distance formula. So I will say LK equals to the square root of x at L minus x at K squared. Yes, you can say x2 minus x1 squared plus you say y at L minus y at K squared. You can also say y2 minus y1 squared. So I'm looking for the distance of LK using the distance formula. My x at L is minus 5. My x at K is 0 plus my y at L is minus 3. My y at K is 2 squared. So LK is the square root of 50. So this distance of LK is the square root of 50. Okay, now I have to find the distance of LM using the distance formula. So I will say LM is equals to square root of x at L minus x at M squared plus y at L minus y at M. I'm running short of space, squared. Sorry for that. So L at M equals to the square root of, what is x at L? It's minus 5. So I will say minus 5. What is x at M? Is 2. Y at L minus 3. Y at M negative 2. So it's going to be minus minus 2. Let me just confirm that I'm not making mistake. Minus 5, minus 2, minus 3, minus minus 2. So LM, guys, you just have to use a distance formula. Minus 5 minus 2 is minus 7 squared is 49. Minus 3 plus 2 minus 1. Minus 1 squared is 1. So LM is the square root of 50. You can also measure the distance of KM. I'm not going to do it. The distance of this side KM, but I guarantee you the distance is not going to be the square root of 50. So the triangle KLM is an isosceles because we see that LK is equals to LM. So it has got two sides that are equal. So that is an isosceles triangle. Isosceles triangle has got two sides that are equal. So 3.2.6, what type of a quadrilateral is KLMN? Remember we set this quadrilateral KLMN, this quadrilateral is a parallelogram, which means that opposite sides of a parallelogram are equal. So this side is square root of 50. If this is square root of 50, even this side is going to be square root of 50 because opposite sides of a parallelogram are equal. Now, if this is square root of 50, even this side will be square root of 50. And what type of a quadrilateral now is it? This quadrilateral, I believe, is a rhombus. A rhombus is a quadrilateral which has got all sides that are equal. But another type of a quadrilateral that has got all sides being equal is a square. But this one, I don't think it's a square because a square, the angle, this angle here needs to be 90 degrees. For all the angles inside the quadrilateral will need to be 90 in order for that quadrilateral to be a square. So I believe here the examiner wants us to say this quadrilateral is a rhombus. Okay, so now let me go to question 4. Let me go to question 4. Okay, now here they say determine the equation of the asymptote on 4.1. So here we are dealing with the topic of functions. Okay, so when you are dealing with a function, the first thing that you must ask yourself, what type of a function is it? So this function f of x, it's a hyperbola function. Hyperbola function, you always see it when x is the denominator. So a function whereby the independent variable x is a denominator, you know that is an hyperbola. An hyperbola has got two asymptotes. It has got the x asymptote and it has got the y asymptote. So how are we going to find the equation of the asymptotes? The first thing that you do, you equate your denominator to 0. This is where you are going to find the equation of the x asymptote. So you are going to say x plus 1 equals to 0. Therefore, x equals to negative 1. So this is the x equation of the asymptote. And the y equation of the asymptote is represented by this number here. This positive 5 represent your y asymptote. So you say y equals to 5. So you get your 2 marks. These are the equations of the asymptote. So they are saying determine y-intercept. Y-intercept, it is found by letting x to be 0. So all the time mathematically, when you are looking for the y-intercept, you let x to be 0. So we come and say f of x equals to minus 3 over x plus 1 plus 5. So then because you are looking for the y-intercept, you substitute x with 0. Where you see x, you put 0 minus 3 over 0 plus 1 plus 5. Just press your calculator. You will see that the answer is 2. So the y-intercept is 2. If the question was, give us the coordinates of the y-intercept, you are going to write it like this. You are going to say 0 and 2. These are the coordinates of the y-intercept. Now they say, give us the x-intercept of the graph. To find the x-intercept, you let y be 0 interchangeably. To find y-intercept, you let x be 0. To find x-intercept, you let y be 0. So I'm going to find the x-intercept now by letting y to be 0. So I'm going to say f of x, which is my y actually, this f of x, equals to minus 3 over x plus 1 plus 5. So this y is going to be 0. 0 equals to minus 3 over x plus 1 plus 5. Now you take positive 5 to the left-hand side. You say minus 5, it becomes negative. Minus 3 over x plus 1. Now you do cross multiply. You're going to have minus 5 times x plus 1 equals to negative 3. So you've got minus 5x minus 5 equals to negative 3. So you've got minus 5x equals to, if you take minus 5 to this side, it's going to be minus 3 plus 5, which is 2. X equals to minus 2 over 5. So that is the x-intercept. That is the x-intercept, which is minus 2 over 5. So the y-intercept was 2, if I remember. Y-intercept was 2. The x-intercept, it's minus 2 over 5. I'm writing these things down because if they ask me to sketch the graph, I will need this information. Now 4.4, they say sketch the graph, clearly indicating the asymptotes and the intercept, you see? So now I want to sketch the graph. So when you sketch the graph of a hyperbola function, you must have the y-axis and you must have the x-axis. So what is, then show me the asymptote. Let me say 1, 2, 3, 4. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. This is the y-axis. This is the x-axis. Minus 1, minus 2, minus 3, minus 4. Now you say, the asymptote. You still remember the equation of the asymptote? X was negative 1. So you go to x being negative 1, you draw a dotted line which must cut x being negative 1. That is the x asymptote. On top of this line, you can write x equals to negative 1. So it is where x is negative 1. So the line has to cut where x is negative 1. That is the x asymptote. The y asymptote, we said it's 5. Remember when we were answering 4.1, we said x equals to negative 1, y equals to 5. So the y asymptote, it's 5. So you go where y it's 5. You make sure that you draw a line that will cut y being 5. This is the equation of y equals to 5. Okay, now let us show the intercept on the graph. Remember the y-intercept, it's here at 2. And where is the x-intercept? At negative 2 divided by 5. Negative 2 divided by 5, it's how much? I think it's 0, 0,4. Negative 0, 0,4. So where is negative 0, 0,4? Somewhere here. And then you write there, at this point, you write that we have negative 0, 0,4. So the graph will go like this. We'll approach our asymptote. We'll never touch the asymptote. Okay. So another graph will be this side. So this is your graph of hyperbola. You name it. You say is the graph of f of x. So you have sketched the graph of the hyperbola. Now they say write down the range of f of x. The range of hyperbola is simple, guys. You just say y can be any number. Y can be any real number, but y should not be the y asymptote. So the y asymptote, if you remember it very carefully, it is 5. I said to this function f of x, it has got two asymptotes. It has the x asymptote of negative 1 and the y asymptote of 5. So y can be any real number, but y should not be 5. So this is how you deal with question 4. Okay, so now we have to go to question, I thought we have equation 5. We have it, but I will have to find it on my desktop for sure. Ooh. I will have to find it on my question 5. Maybe it's on this PDF. Yes. This is question 5. Okay. On question 5, they say write down the coordinates of A. Yes. A, they are referring to the midpoint of our quadratic graph, and which is f of x. F of x, it's equals to half over x plus 5 squared minus 8. Actually, this quadratic equation or this quadratic function is in this form. F of x equals to a x minus p squared plus q. So when we say this p and q represent the turning point of a quadratic graph. So this guy says write down the coordinates of A on 5.1. He's looking for the coordinates of A. And this coordinates of A is the turning point of a graph. So it is easy to see the turning point of a graph as long as the function is written in this form. f of x equals to a into x minus p squared plus q. Actually, there are two ways in which we can give you the quadratic equation. We can give you in this way, f of x equals to a x squared plus bx plus c, or we can give it to you in this way, f of x equals to a x minus p squared plus q. So in this form, you can be able to see the coordinates of the turning point. It is easy, if the function is in this form, it is easy to see the coordinates of the turning point. So 5.1, when you answer it, you are going to say, okay, you go to this brackets here, x plus 5. You say x plus 5 equals to 0. Therefore, x equals to negative 5. This means that the x turning point is negative 5. The y turning point is so easy that you don't even have to calculate. This number at the end here, negative 8, represent the y turning point. So the coordinates of A, it's minus 5 and minus 8. A is the turning point of a quadratic graph. And you can see it from the way the equation is written. It's easy to see the turning point. Write down the range of f. So we are asking for the range of this quadratic graph, which turns at a. So we say the lowest value of y we can have. Let me write the coordinates of a next to this graph. Minus 5, minus 8. The lowest value of y this quadratic graph can have, it's minus 8. So we say, when we give the range, we say all values of y, they are greater than or equals to negative 8. You can even say y is the element of real number. You can say y is the element of real number such that all values of y are greater than or equals to negative 8. Let's write it this way. So because if the graph turns at negative 5 and negative 8, the lowest value of y the graph can have is negative 8. This turning point is actually called the minimum point. To me, I can say it's a minimum point, or it's where we find the minimum value, or it's where we find the lowest value of a function. So we use this idea that the lowest value of y is negative 8. Then we say all values of y are greater than negative 8. Y can be negative 8, or all values of y can be greater than negative 8. So that is the range. That is why it's 1 mark. It does not need you to calculate. You just have to make use of the turning point of a quadratic graph. So now they say calculate the values of m and n, or they are looking for the coordinates of t, which is m and n. I just went straight to answering the question. I did not read the information, which is what you must not do in the exam. So I will go back to the information and see what is it that I might have missed. So A is the turning point of F, that it was easy to see that. The axis of symmetry of F intersect the x-axis at E, and the line G D M and N. C is the y-intercept of F and G. So what they are saying here actually, guys, is that this line of axis of symmetry pass through G at D, and it also passes through A, the turning point. Obviously, axis of symmetry has to pass at the turning point. So this axis of symmetry, it is normally found by saying negative B over 2A. The axis of symmetry of a quadratic graph is found by saying negative B over 2A. And negative B over 2A, we know that it is the x turning point of a quadratic graph. So if you are calculating for the x turning point of a quadratic graph, whereby the quadratic function is given in a standard form, you can use negative B over 2A. But this time around, we do know this x turning point is negative 5. So we know that the equation of axis of symmetry is -5, which means that at D, the M coordinates is -5. Why am I saying at D, the X coordinates is -5? Remember, this is the line of symmetry. So this line of symmetry, on the line of symmetry, X will always be -5. So if we are at D, this X, which is M, the X coordinate is -5. Even if we are at A, the X coordinate will be -5. So the X coordinate will always be -5 along this axis of symmetry. Now, okay, so if you can see here, guys, if you pay attention to details, we see that the coordinates of D, X we said is -5. We don't know the Y coordinate, which is N, but we know that this D, it is found on a straight line G of X. So we can use the function G of X to find the Y coordinate, because G of X passes through D, where at D, X is -5, Y is not yet known. So I'm going to say G of X equals to 1 over 2x plus 9 over 2, and say I'm looking for y, whereby x is -5. So I substitute x with -5. I'm looking for the coordinates of D, and at D, x is -5. So y equals to -5 over 2 plus 9 over 2. Just press your calculator. You'll see that the answer is 4 over 2, which is 2. So the coordinates of D, it's -5 and 2. So we answered the value of M and N. M is -5, N is 2. So now the last question, calculate the area of OCDE. Wow. The area of OCDE, OCDE. So this is, and OCDE is a trapezium. A trapezium is a geometric figure which it has got a pair of, which has got parallel lines on it. Okay, let me show you what is a trapezium. As long as the opposite, let me say, I have this shape, this side, which is opposite to this side. As long as this side are parallel, this figure becomes a trapezium. So in a trapezium, we have got one pair of opposite side which is parallel. Okay, so you can look for a trapezium formula and you calculate the area of the shape OCDE. Unfortunately, I forgot the formula for calculating the area of a trapezium. But if I recall, it's something like half, okay, times the sum of these lines that are parallel. So you say DE plus OC, then you multiply by the perpendicular height of this trapezium. For sure, the perpendicular height will be a line from one parallel line, the distance from one parallel line to another. Okay, so yes, if I can know the distance from, okay, so I'll say times, I'll just call that height. I'll say times height. This height, remember, my height in this case is the distance from one parallel line to another. Yes, this is my height. So you say half of, if this is AB and this is DC, you say half of AB plus DC times height. Go and confirm the formula. This is what comes to my mind, and I think it's right, but just go and confirm it. You know, the only time when I say something is when I am guaranteed and when I'm so sure. So if I'm not sure with something, I will say, go and confirm it. I don't want you to say that guy gave me a wrong information. So if you are calculating for the area of this OCDE, you can use the formula of a trapezium because you see that OC is parallel to DE because they are both vertical lines. They are both vertical lines. Okay, let me see, how can I find this area without using the formula of a trapezium? Let's say I'm in exam and I forgot the formula. What can I do? What can I do? I can do something like this. I can say, I can see two shapes on this OCDE. I can say this, I can create a rectangle. I can create a line which is parallel to this line. And then this shape here is a rectangle. So I can calculate the area of a rectangle and then go and calculate the area of this triangle here, which I believe is a right angle triangle. So you find the area of a rectangle, you add it with the area of a triangle, then you get the area of the whole shape OCDE. So kana XE here, the x coordinated is -5, which means the distance from O to E is 5. So we have the distance from O to E, it's 5. And then we know that at N, okay, we know the y coordinate at N. We said D, it's -5. What was the y coordinate? It was -5 and what? I wish I remember that y coordinate, the value of N. Oh, I said it's 2 -5. Yes, it was 2. -5 plus 9, it's 4. Yes, it's 2. So, which means that the distance from E to D is 2. Okay? Yes, the distance. Okay. So now, what are the coordinates of C? Maybe that's what we have to ask ourselves here. Remember, C is the y-intercept. So, y-intercept, we let x to be 0. We just substitute x with 0 and we find the y-intercept. So it's a half of 0 plus 5 squared minus 8. This is 25. 5 squared is 25. Half of 25. 25 over 2 minus 8. 2 times 8 is 16. 25 minus 16 is 9, so it's 9 over 2. So the C is 0 and 9 over 2. So which means that, okay, I can say if I just call this point M here, I can have the distance from M to C, because I know that the distance from 0 to C, it's 9 over 2. So if I say 9 over 2 minus and pull out this distance of 2 here from O to M, minus 2, 9 over 2 minus 2, 2 times 2 is 4. So I have a 5 over 2. So it's 5 over 2. So the distance from M to C is 5 over 2. And the distance from O to M is 2. So now the area will be like this. I will say the area of this trapezium OCDE is made up of a rectangle, which is 2 times 5. That is the area of a rectangle, plus the area of a right angle triangle, which is a half times base. My base is 5. My height, in this case, it's 5 over 2. So my area is going to be 10 plus 5 times 5 is 25. 25 over 4. 10 times 4, it's 40. Plus 25, it's 65 over 4. So that is the area of OCDE. It's 65 over 4. Grade 11s, it was great having you here. Please subscribe to my YouTube channel and keep visiting the channel so that you can learn some mathematical ideas. Thank you so much. See you next time.